So last time we talked about how to add, subtract, multiply polynomials. Today we're going to talk about how to divide them, right? So first of all, we have a polynomial, and we're first going to divide by a monomial. So basically, like you see in this first example, I have the polynomial on top, and the denominator is a monomial, right? Having one term. All right, so the way we're going to divide that is we're going to split up the polynomial, and each term is going to get its own denominator. All right, so if you look at the numerator, the polynomial in the numerator, how many terms does that have? It has 3 terms, and we split it up into 3 different fractions. So the first fraction is going to be 20 c to the 4 d squared f over 4 cdf. Now the next one has a negative in front, so we say minus, and the fraction bar, 16 cdf squared over the same denominator, and then plus 4 cdf over the same denominator. All right, now it turns into 3 different mini problems like you did in the last section, and we can just simplify them. So let's simplify that first one. I like to take care of the numbers first. So if I reduce the 20 and the 4, I get a 5. Now, c to the 4 on top, c to the 1 on the bottom. I have c to the 3rd on top or bottom? On top. D squared on top, d on the bottom. How many on top? 1d on top. And what happens to the f? They go away, and it turns out I don't have any denominators left for this one, which is fine. Do we write d to the 1st or just d? Just d. All right, so next I have a minus sign. The 16 and the 4 reduce to 4. What happens to the c's? Cancel. What happens to the d's? Cancel. How many f's? Where? 1 on top. Plus. Okay, so nothing or 1, right? Everything on top cancels with everything on the bottom, so I just put a 1. Most common mistake is when students cross everything out, they just leave it blank, and they don't put the 1 there. So watch out for that. All right, and that's your final answer there. All right, now what if the denominator has more than 1 term? Then we actually have to divide, and there are 2 ways of dividing. The first is long division, which we're going to do first, and then synthetic division, which we're going to do after. All right, so you learned long division back in elementary school. Let's just remind ourselves how the process works, right? So suppose you're going to divide 251 by 4, right? Just 2 random numbers. So remember how I put the 4 out here, and it's going to be divided into the 251, right? And what did I do first? What do I ask myself? Right, 4 goes into 25 how many times? And it's 6 times. Then what? Well, we're not going to do decimals. We're going to do remainders, even further back. So now what do I do? 6 times 4 is 24. And then what do I do? I subtract. And I get a 1, right? And then what do I do? I bring down the 1. Remember the good old days? And now what do I do? Now the whole algorithm starts all over again. So how many times does 4 go into 11? Twice. 2 times 4 is 8. And I subtract, and I get a remainder of 3. All right, do you remember that? And we would write it as 62, remainder 3. Another way to write it is this. We could say 251 over 4 is equal to 62 plus 3 over 4. That's another way of writing it, okay? And now if you multiply this out, 62 plus 3 over 4, if you do common denominator, you get 251 over 4. It's like magic. So those are two different ways of writing it. Okay, so now let's do polynomial long division. We're going to do long division, but with polynomials, okay? Now, if you like, you can just sit back, watch. I'll stop the video and give you a minute to copy, okay? So what we're going to do is this. Same way, we're going to put the x minus 3 out here and the x squared plus the 7x minus the 30 in there. Okay, now, the process is very, very similar. What I do is this. Take the first term with the first term, and I divide. So I say, on my scratch paper, x squared over x gives me what? X. That goes here. Now, in my number example, when I put the 6 up there, what was the very next thing I did? 6 times 4. Right, so now I'm going to do the same. I'm going to do x times this entire thing, and that'll give me x times x, x squared, x times negative 3, negative 3x. Now I need to subtract, okay? So if I'm going to do x squared minus x squared, I can do two things. Subtract, or I can change the sign and add, because they're the same thing. If you change the signs and add, it's the same as subtracting. So here's what we're going to do. We're going to change everybody's sign and just add them. So x squared and negative x squared goes away. 7x and positive 3x, 10x. Now what do I do? Bring down another term, the 30. Negative 30, and then it all starts all over again.
Wouldn't it work out the same if you just left it positive?
Right. Right.
What's the benefit of
This is less, it accounts for less mistakes, I've noticed. Okay, so now the whole process repeats. First term with the first term, 10x over x gives you what? 10. So I put a positive 10 here. Now what's the next step? Multiply 10 by x minus 3. So it's 10x minus 30. And then I'm going to change the signs and add. Goes away, goes away. What's the remainder? 0. The remainder is 0 because it went away. Okay? And that's how we do it. Now, hang on. So this number, this up here, is called the quotient, and that's my answer. So the answer is x plus 10, and if the remainder is 0, you don't have to write anything. All right? I'll stop the video for a minute and give you a chance to write. Next one is written in a different format. You have the polynomial times this raised to the power of negative 1, which means to make the exponent positive, what should I do to that term? Move it to the bottom, right? So I can just rewrite this, and it'll look like this. X squared minus 13x plus 12 over x minus 1. And now it's just a division problem. So let's divide with this one. X minus 1 out here. And inside I have this. Okay, now it's always the same process. Take the first term with the first term. Don't be afraid to write down a few steps. I always do. X squared over x gives you x, and I put that up here. Now what? Multiply x times x minus 1, so you get x squared minus x. Now what? Change the sign and add. Okay. X squared and x squared go away. Negative 13x, positive x is negative 12x. And what do I do now? Bring down the positive 12. And now, all over. First term with the first term. Negative 12x over x is negative 12. Negative 12. Now I multiply negative 12 times the red parenthesis. Negative 12x plus 12. Change the signs and add. What's the remainder? 0. So what's my answer? X minus 12. One more time. So we're going to divide first by long division, and let's see what we'll get. So x plus 3 out here. We haven't even touched synthetic division yet. So right now we're just doing long division. Right. I haven't taught you synthetic division yet. We're just doing long division. Okay? I'm going to speed things up just by a hair this time. So first over the first. 2x cubed over x gives me what? 2x squared. That goes up here. Now what do I multiply that by?
2x.
Okay, so I get 2x cubed plus 2x squared times 3 gives me 6x squared. Now, we subtract. The 2x cubes go away. If those first terms don't go away, you're doing something wrong. So go back and check. And if I subtract the second terms, I get how much? Negative 3x squared. Now what do I bring down? Negative 4x. Just one at a time. Don't get too ambitious. Okay? Now, first term with the first term. Negative 3x squared over x gives me what? Negative 3x. And when I multiply by x plus 3, I get negative 3x squared. And then what? Negative 9x. Right? So I have negative 3x times 3, negative 9x. Now, I'm going to subtract. 3x squares go away. And here I get positive 5x.
Wait, why positive? Oh, wait, not.
Now what do I need to bring down? The 15, and it's a positive 15. So 5x over x gives me what? 5. And I get plus 5 here. Now I multiply 5 times x plus 3, and I get 5x plus 15. And when I subtract those, what do I get for my remainder? 0. So my answer is 2x squared minus 3x plus 5. Now, let's talk about synthetic. And thank you for bringing that up. What does synthetic mean? Fake, man-made, right? Not natural. And that's what synthetic division is. It's the fake kind of division. It's a quicker way to get you to the answer. Okay? Give me a second. So the thought behind it is this. When we're doing this long division business, really the x cubed and the x squared and the x are just being carried along as labels. We're not doing much with them. The stuff we're really playing with are the coefficients, right? It's the 6 and the 2 and the 3 and the 4. So how about we could get rid of the variables altogether and just deal with the coefficients? That's what synthetic division does. So what we're going to do is this. We're going to make a chart for ourselves. A chart that looks like this. It's sort of a half rectangle. Okay? Now, inside here, we have to put the coefficients of the polynomial. So where is that polynomial? It's this 2x cubed plus 3x squared minus 4x plus 15. All right, first you have to check that your exponents are in the correct order from the highest to the smallest. So let's take a look at the exponents. I have x to the 3, 2, 1, and here that's just x to the 0. So I'm good. Okay? Now I put in my coefficients. So let's see what coefficients I have. I have a 2, I have a 3, What's next? A negative 4 and a positive 15. All right, now what is going to go on the outside of this? I take my x plus 3 and I set it equal to 0 and I solve for x. So what do I get for x? Negative 3, and it's that number that goes up there. Now, here we go. The first number comes down for free. It's a freebie. So the rules of the game are, whichever number makes its way down below the line gets multiplied quickly by that negative 3. Okay, that red one. So the 2 gets multiplied by negative 3, and what do we get? Negative 6. And now here, I add vertically. What do I get? Negative 3. Just add. Okay? Now, whatever makes it down there gets multiplied by what? Negative 3. So I get a positive 9. I add vertically. What do I get? 5. Now what do I do? Multiply by negative 3. I get negative 15. I add. What do I get? 0. Now, that last number is your remainder. Whatever it may be. It could be 0, it could be negative 5, it could be 257. That number is your remainder. Now from here, we're going to get the quotient. Okay, and we already have it in the making. All right? All right, the rule is, whenever a polynomial goes through this division process, the highest exponent always gets reduced by 1. What was the original highest exponent? 3, right? The original highest exponent was 3. Now it's going to get reduced by 1, and it's going to be a 2. So I'm going to get an x squared, an x to the 1, and an x to the 0, right?
Why is it reduced by?
So that's just the rule. So here's how we do this. I write down my coefficients that I got from the bottom here. So 2, negative 3, and positive 5, right? That's what I got. And now I put in my variables. So x to the 3 gets reduced to x squared, and then x to the 1, and over there x to the 0, it's just nothing. So the final answer is 2x squared minus 3x plus 5. And look, it's exactly what we had gotten before. Okay? Now, it seems longer, but really it's much, much, much quicker. So let's do a couple more synthetic. Here's the first one. All right, now we make our chart. Okay? Now there is a bit of a problem here. Let's take a look at the exponents. I have a 4, but where's my 3? I'm missing a 3. That means I need to account for that. And then after that, I have a 2, a 1, and a 0, so I'm good. I'm just missing that 3. All right, so let's put in our coefficients. The first one is a 4. Then I'm missing the x cubed term, right? The a cubed term. So in the place of that, I put a 0. And you have to do that, otherwise there is no way your answer will come out right. And then what goes after? 2 and negative 4, positive 12. What goes out here? Negative 2, right. Okay, so first number comes down for free. Now, what happens to the 4? Multiplied by what? Negative 2, so I get negative 8. I add this way, I get negative 8. Hang on. I multiply this way, I get 16, and when I add, what do I get? 18. Now what? When I multiply, what am I going to get? Negative 36. When I add,
Wouldn't it be negative 16 because it's negative 8 times 2?
it's negative 8 times negative 2, so it's positive 16.
Where is there a negative 2?
Our number is like a negative.
So when I add here, I get negative 40. And here, positive 80. So what do I get? 92. And what is that 92? That's my remainder. So let's write down the quotient now. So I have a 4, a negative 8, a positive 18, and a negative 40. So here's what I get. What's the first variable going to be? A cubed, and then a squared, and a to the 1, and the last one is alone, plus the remainder now, and that's 92 over a minus 2, a plus 2.
Why didn't you do why didn't you just start with 8 to the 4?
All right, so we have 2 out here for this one. And are we missing anything?
Yeah, 2.
Right, so it's 6, negative 8, 0, 12, negative 14. So 6 times 2 is 12. Adding is 4. Times 2 is 8. Adding is 8. Times 2 is 16. 28. 56. And adding we get, what do we get? 42. Okay? So I have b to the 4, b to the 3. I'm missing the b squared, so I have to put in the 0. Now, if you don't put in the 0, there is no way your answer will come out right. So the polynomial that I get out of here is 6b to the 3 plus 4b squared plus 8b plus 28 plus 42 over b minus 2. All right, so far things have been easy because I have been dividing by things, by binomials where the coefficient has been a 1, right? So now we're going to take care of, well, what if the coefficient is not a 1?
And that one, the answer.
What if the divisor does not have a coefficient of 1? Like you see in this first case, the first term here is a 2. We're dividing by 2x plus 1. All right, so because that number is a 2, the first thing we have to do is divide everything here by a 2. Okay? Because this number is a 2 here and not a 1. And now we're going to get fractions. I'm warning you now, you're gonna have to work with fractions, okay? So,
Would it be easier to put the number as negative 1/2?
okay, so here's what we're going to do now. Once you divide, what do I get? I get 4x to the 4 minus 2x squared plus half x plus 2 divided by 2x plus 1. All right, so let's see what we're going to get for coefficients here. I haven't divided that 2 out yet. I've only divided it in the main polynomial. Okay, I haven't touched the second polynomial yet. Okay, now, my coefficients. Am I missing any exponents? The 3, right? So it's going to be a 4, a 0, negative 2, 1/2, and 2. So I have a habit. Once I do this, I go through and I now count my exponents, so to speak. So I know that this is supposed to be x to the 4, 3, 2, 1, 0, and I'm done. I've got to go all the way to the 0. Okay.
Why did you put negative? Oh.
So let's see what we're gonna put out front. Remember what I said before is you take that number, that 2x plus 1, set it equal to 0. So 2x is negative 1 and x is what? Negative 1/2. So that's the number that goes there. Yeah. You won't get it. You won't get the right answer otherwise. because we're dividing by 2x and not just x. Okay, now, the first one comes down for free, so it's 4. Now, I have negative half times 4. What is that going to give me? Negative 2. I add and I get negative 2. Now I have negative half times negative 2. So is that positive or negative? Positive 1. I add and I get minus 1. Now I get negative half times negative 1, which is positive 1/2. What do I get when I add the 1/2 and the 1/2? I get a 1. Because if I have half a chocolate bar and somebody else gives me another half a chocolate bar, now I have a full chocolate bar. And now if I multiply the negative half times the 1, negative 1/2. Okay, now what's 2 minus a half? 1.5, which in mixed number, improper fraction, 3/2. Okay, now let's see what the polynomial is going to be. So it's 4x to the what? 3 minus 2x squared minus x plus 1. Okay, now I have plus, all right, 3/2, the remainder, over 2x plus 1, right? But that just looks ugly. So let's just clean it up. So 4x cubed minus 2x squared minus x plus 1 plus, so you know what you do is you take that 2 and just move it down one flight. So it's 3/2 times 2x plus 1. Either way, this is fine. This is much less of a headache. All right, we're gonna do one more. Last one. Okay. So last one. All right. So what are we gonna divide everything by? 3. Divide by 3. Divide by 3. Ooh, lots of fractions coming up. Fun. So I get 2c cubed minus 17/3c squared plus 2c plus 8/3 divided by 3c minus 4. All right, so let's put down our coefficients. I don't have any exponents missing, so it's 2, negative 17/3, another 2, and then an 8/3, right? What's going to go on in front? Negative or positive 4/3? Positive 4/3. All right. Ready? Two comes down. Now, I'm going to multiply. 4/3 times 2. Nobody's going to take points off for you, if you write stuff down. So write them down. What do we get? 8/3. Now, let's add. Negative 17 plus 8/3 will be negative 9/3, which is how much? It's negative 3. How nicely does that work out? Now, 4/3 times negative 3, what is it? Negative 4. And when I add, what do I get? Negative 2. Now, 4/3 times negative 2 is what? Negative 8/3. And don't you just love it when that happens? Because what's the remainder? 0. And now my quotient is going to be 2c squared minus 3c minus 2, and that's the answer. Okay, one last thing, a little bit of
No more.
a vocabulary. This polynomial that we get after doing synthetic division, who knows what it's called? Well, it's the polynomial after the reduced exponent. It's called a depressed polynomial.
That's literally me.
That's what it's called. It's called a depressed polynomial.
Like, I really relate to this polynomial.
And yes, there are millions of jokes. All right? So that's the homework for this.